Okay, so what you need to know about this is that a sample space is the set of all possible outcomes in an experiment. So it's all the different ways that this can happen. So for example, if I have two coins that are being tossed, there are three ways that I can write out the sample space or think through. And so I'm giving you these options because everybody thinks a little differently. So I can go ahead and just make a list. So I can list them out, a tree diagram or a table. And so I'm going to show you those different methods and when they're best for different situations. But if I'm flipping two coins, my results of the first coin are heads or tails, and the results of my second coin are also heads or tails. So I can make a list, and this list represents both coins are heads and both coins are heads. This one shows the first coin is heads and the second coin is tails. This one shows the first coin is tails and the second one is heads, and then this one shows that both are tails. So there are four possible outcomes, and this is the sample space. Heads, 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 tails, tails, heads, tails, tails. All right. If I did it as a table, this would represent the first coin being flipped. So I have heads or tails. This is the second coin being flipped, heads or tails. So my sample space is both our heads, just like we had up here. The first one is heads and the second one is tails, just like we had here. The first one is tails and the second one is heads, like we have here, or both are tails. So this also shows right here is my sample space. I can also draw a tree diagram. So a tree diagram, this first column is my first coin. This second column is my second coin. And what happens is this represents an outcome, and it's the result of the first coin being heads and the second coin being heads. So here is my outcome. This tails represents the first coin being heads and the second coin being tails, like we have here. And then this represents my first coin being tails and my second coin being heads and tails here. So this is actually what we count as far as the number of outcomes. The previous columns just show us what's happened prior to that led to that outcome. But that would be my sample space as a tree diagram. Okay, so we're going to do a couple examples of listing out our sample space. So in this first example, I am rolling one dice. So when I roll one dice, I can have a 1, a 2, a 3, a 4, a 5, or a 6. So my sample space is actually, and we do these funky brackets, and we list them out. A 1, 2, 3, 4, 5, or 6. So that is my sample space. And oftentimes we do it with a capital S. So it's all the possible outcomes. So now rolling 2 die gets a little tricky, and you can draw it as a list. I would lose track of things if I were drawing it as a list. So I actually like to, you would also do a tree diagram, but it's going to get really bunched up when we start getting onto that second branch of the second die. So what I like to do when there's two events is I actually really like the table approach. So I like to list the possible outcomes of the first die. So a 1, a 2, a 3, a 4, a 5, or a 6. Let's say that one's blue. And my second die is red. So I have a 1, a 2, a 3, a 4, a 5, or a 6. And so I want to list the sample space, so all the possible outcomes of rolling those 2 die. Sorry, this is not going to be nice and pretty for people who need straight lines. My apologies. All right, so this first box is going to represent a 1 with the blue die and a 1 with the red die. So it would be 1, 1 would be that piece. This would represent a 2 on the blue die and a 1 on the red die. This one would be a 3 on the blue die, a 1 on the red die, a 4, and a 1, a 5 and a 1, or a 6 and a 1. So I'm going to go ahead and fill out the rest of this table to show all the possible outcomes, or the sample space of rolling 2 die. Okay, so this is my list of total outcomes, or my sample space. So it is 6 rows of 6 columns, because there's 6 outcomes on the first die and 6 outcomes on the second die. So there are 36 total outcomes that could possibly happen when I roll 2 die. Because if you notice, this represents a 4, 3 represents rolling a 4 on the first die and a 3 on the second die, versus this 3, 4 represents rolling a 3 on the first die and a 4 on the second die. So those are 2 different outcomes. So I have to account for all the outcomes. So this would be my sample space. Okay, so in this one, I am flipping a coin and I'm rolling a spinner with 4 equal parts. So I'm just going to sketch that out. So A, B, C, and D, and here's my spinner. All right, so I know flipping a coin has heads or tails. So I can find my sample space by either making a list, making a tree diagram, or making a table. So I'm just going to make a list on this one because the outcomes are pretty straightforward. So I know that I can have heads and roll an A. I know I can have heads and roll a B. I know I can have heads and roll a C, or I can have heads and roll a D. So those are all the possible outcomes with heads of the coin. So then I'm going to go to tails, and tails can roll an A, tails can roll a B, tails can roll a C, or tails can roll a D. So my sample space are these 8 outcomes. If I wanted to put it in proper notation, I would have heads A, heads B, heads C, heads D, tails A, tails B, tails C, tails D. That's the sample space. All right, so for the last example, I would like you to try it using one of the 3 methods that make the most sense to you. So having 3 children. So what are all the possible outcomes, or what's the sample space? What's the total amount of ways that I can have 3 children depending on their gender? All right, so on this one, I did it 2 different ways. A 2-way table won't work because we're talking about 3. So I just went ahead and listed out in purple. I thought about, okay, so what are the options I can have for gender? So I can have all boys. I could have 2 boys and a girl. I could have 1 boy and 2 girls, or I could have all girls. And so then I just listed out by order, birth order, what that would look like. So here, all boys, boy, boy, boy. This would be 2 boys and 1 girl. So I could have the 2 boys be the oldest and the girl be the youngest. The girl could be in the middle, or the girl could be the oldest. And then the same for 2 girls and 1 boy. The boy could be the oldest, in the middle, or, this should say girl, girl, boy, or he can be the youngest. And then the last option is obviously all girls. So then I also did a tree diagram. So this is the first child, or the oldest, can be a boy or a girl. Then the second child can be a boy or a girl, boy or girl. And then the third child, boy or girl, boy or girl, boy or girl, boy or girl. So then I created my sample space. So this represents boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. So either way, I arrived at my 8 samples. The sample size is 8, and then these are the lists of either the purple or the blue, whichever makes sense to you. The other part of our objective is to be able to identify the event. So the event is the desired outcome. We're not going to do a whole lot with this other than just pick it out right now. And then as we move through this probability unit, that's going to help us create or identify the actual probabilities, because the desired outcome, or the event, is what we're looking for. So let's look at some examples. All right, so remember, the event is the desired outcome. So in example 5, the desired outcome is rolling a 4. So we're revisiting that rolling 1 die. and that is my event, is that one way that I can roll a 4. So example 6, the event or the desired outcome is rolling a 3 and a 4. So it doesn't say which one has to come first, but this way is a 3 and a 4, and here is a 3 and a 4. So those are, the event is rolling a 3 and a 4, and there are 2 ways to get that event. Okay, if I'm rolling 2 die again, rolling a sum of 5. So the event is a sum, meaning when I add them together, I get 5. So I can have a 1 and a 4, a 2 and a 3, a 3 and a 2, or a 4 and a 1. So there are 4 ways to get the event of rolling a sum of 5. Okay, we're going to go back to the spinning a 4 divided parts A, B, C, D, and flipping a coin. So the event is spinning an A. So I have an A here and I have an A here. So there are 2 ways to get to that event A. Or I could look at my list and I can see there are 2 ways to get event of spinning an A. All right, in my example of having 3 children, I want to know the event of having a boy as the oldest. So that is this one, this one, this one, and this one. So there are 4 ways that I can have that event of having a boy as the oldest. And the last example, having all girls. So the event is 3 girls. There's only one way I can do that.